Alright, hey guys, we're working through the first proof question of this chapter. If you guys have any questions you need solved, just let me know what number in the comments section. We're doing cosecant of x, or cosecant of x. Okay, so the first question is, what does this ask us to do? It's basically asking us to find the proof that cosecant x is actually, once you take the derivative of it, it's going to be negative cosecant x cot x. Now, how do we do that? We just take the derivative. Basically, the only thing different between this question and all the previous ones that we did is this one that gave you the answer. In theory, when you finish your derivative, you should get negative cosecant x cot x, or you know you did something wrong. Alright, so how do we take the derivative? Well, we have to use one of those trig identities that you might not remember from high school. And they're also in the appendix of the textbook. So what exactly is cosecant x? Well, it's defined as being 1 over sine x. And so when you go 1 over sine x, can you take the derivative of that? Well, a big hint is it's just a fraction. And as soon as you see a fraction, it means you have to use the quotient rule. So the question probably wants us to also practice our derivative rules and memorize some. There's two we're going to need. The first one is the derivative of sine x, which is cos x. And the second one is the derivative of 1 is equal to 0. Right. So now that we realize it's actually asking us to take the derivative of a fraction, we know we're going to have to use the quotient rule. So the first thing is, what is your top in here? Your top is just 1. And what's the derivative of 1? It's 0. And what's your bottom? Your bottom is sine x. And what's the derivative of sine x? It's cos x. So now we have everything we need to start solving the problem. So first we'll go and we'll put basically all of our g primes and h primes into the formula. G prime is 0. 0 times sine x is going to be 0 because anything times 0 is 0. And then you have a minus 1 cos x. And then on the bottom you just have sine x squared. And of course all of that comes from the table above. You're basically looking on the table, finding the value, and putting it into the formula. Alright, now we're going to use a little bit of a trick. So the trick here basically works like this. I have a little proof of it in the corner. If you take 1/6, it's the same as a third multiplied by a half, right? So if you go 1/3 times 1/2, you're going to get 1/6. So you can take that 1/6 and you can kind of break it into little pieces if you want to. And we're basically going to use that on this next step. So once we simplify, we end up with a negative cos x over sine x times sine x. So the question is, how can we split that apart like we did with the 1/6, right? Well, the answer is that basically we can just make it into negative cos x over sine x times 1 over sine x. And we're basically doing it the same way before. And to show you further proof here, I just replaced the 1 on the top with an x. And you can see that we can split this expression apart too. Basically all we're doing is we're splitting that 6 on the bottom to be a 3 times 2. And then we're just making the x on randomly one of the two fractions. And we're just multiplying by 1, because if you multiply something by 1, you don't change this value. So you can see that if you work your way through the multiplication going this way, it's going to go back to x over 6, and you can split it apart by going that direction, right? And then on the next line, just for fun, to make it a little bit more complex, I've thrown in two x's, one on the top, one on the bottom, and you can split this one apart just the same, right? So that should prove to you mathematically, I hope, that the trick I pulled on this last line totally works. And so now, if we look at these two expressions, what do they mean? Well, the first one, cos over sine x, well that's cot of x. And then the 1 over sine x, well we talked about that earlier on the first slide, that's just cosecant x. So we've reached our endpoint that we wanted to reach. So that's it, that's our proof. We went from the start, and then we worked our way through the steps, and got to the end. Yeah. So, if you enjoyed this problem, or you need help with another problem, just feel to reach out and let me know which one. I have about another 24 videos or so in this section. I think over there should be a playlist, and further over should be another recommended video. Have a good day, guys.